Determine all solutions for the following equation over the specified domain. So our equation is 2 times cos of x plus pi on 6 plus 1 equals 0. We're going to solve that for x is an element of minus 2 pi to pi. So this here is the domain which we're solving it over, and we'll just keep in mind that that includes a period and a half of this cosine graph, and that's because the period of a sine or cosine graph is equal to 2 pi divided by n, where n is the value that's multiplied by the x. So in this case, n equals 1, which means that our period is simply 2 pi. So as the period is 2 pi, 1.5 periods fit inside that. So potentially we're expecting between 3 and 4 solutions to appear for this equation. So to be able to solve this equation, we're going to get cosine by itself. So we're going to subtract 1 and divide by 2. So we're going to solve the equation cos of x plus pi on 6 is equal to negative 1/2. And now 1/2 is an exact value that you should know for sine and cosine. So the reference angle for that is theta is equal to pi divided by 3. So that means we're dealing with this angle here. So that there is pi divided by 3, and that gives a cosine value of 1/2. However, we need a negative half, so we're in the second and third quadrants where cosine is negative, and these two angles here both give negative 1/2 for cosine. So if the symmetry of the first quadrant is theta, then this is pi subtract theta, and this quadrant is pi plus theta. And this means that we want x plus pi on 6 to equal pi minus theta, or pi plus theta. So substituting this in, we'll have x plus pi on 6 is equal to pi minus pi on 3, or pi plus pi on 3. And now if we simplify this a little bit, we're going to have x plus pi on 6 is equal to, we're going to have pi minus pi on 3, which is 2 pi on 3, but I'm going to write that as 4 pi on 6 so that we've got a common denominator on the left-hand side and the right-hand side, and you'll see why that's going to come in handy in a moment. And for the second part, we have pi plus pi on 3, which is 4 pi on 3, which I'm going to write as 8 pi on 6 again, so we have a common denominator. Now the reason why I wrote all of these as over 6 is because we now need to subtract pi on 6 from each of these terms. And the reason we do that is we want to get x by itself, so we'll have x is equal to, and then we have 4 pi on 6 minus pi on 6, which will give us 3 pi on 6. And for the second part, we'll have 8 pi on 6 minus pi on 6, which is 7 pi on 6. And you'll notice I've left a gap here, and that's because we're going to go and find, hopefully, some more solutions that fit in that domain. At this point, though, we can see that the largest possible value of x for this domain should be pi, which is the same as 6 pi on 6, which means that 7 pi on 6 is outside the domain. So to find the other values that are potentially inside this domain, we're going to subtract the period, which is 2 pi, from each of these solutions. So the next solution that could come up would be 7 pi on 6, subtract 2 pi, but this 2 pi, which is the period, we could write as equaling 12 pi on 6. So we're going to subtract 12 pi on 6 from that solution, and again we can take our 3 pi on 6, so 3 pi on 6, and subtract 12 pi on 6. And these are two more potential solutions that might be inside our domain. We'll just do one more of those. So we're going to have our 7 pi on 6, and I'm going to subtract 2 periods from that, which will be 24 pi on 6. And now when we evaluate that and simplify it down, we're going to have 7 pi on 6 minus 24 pi on 6 is going to be negative 17 pi on 6. We're going to have 3 pi on 6 minus 12 pi on 6, which is minus 9 pi on 6. Then we're going to have 7 pi on 6 minus 12 pi on 6, which is minus 5 pi on 6. Then we have 3 pi on 6, and we did have 7 pi on 6, but again, we know that that's outside the domain. We also need to inspect our smallest values. So negative 17 pi on 6 is less than negative 2 pi, so it is also outside of the domain. So all of this working has led up to us finding the x values that are a solution to this equation. So we have x is equal to minus 9 pi on 6, which can be simplified down to minus 3 pi on 2, minus 5 pi on 6, and finally 3 pi on 6, which can simplify down to pi divided by 2. So they are the four solutions to this equation over the specified domain. On this slide, we've graphed y equals cos of x plus pi on 6 in blue, and in red we've graphed y equals negative a half. And that's because we solved the equation cos of x plus pi on 6 equal to negative 1/2. So by sketching both sides of that equation and looking for the points of intersection, we can find the solutions. So we have negative 3 pi on 2, minus 5 pi on 6, and positive pi on 2, which are the same solutions that we found by hand on the previous slide.